Good afternoon, everybody. So today would be Thursday, October the 13th. So this would be the last lesson of this week. Tomorrow, Friday, is going to be your catch-up period to finish any of the worksheets that you have not finished. So day number 5, optimizing surface area and volume. Now, just a reminder, tomorrow, Friday, all 3 of the worksheets from this week will be due. So that's day 3, composite figures. Day 4, optimizing area and perimeter. And today, optimizing surface area and volume. Now, if there's one thing to take away from last lesson, it was that a square will give you the maximum area with fixed perimeter, and will give you the minimum perimeter with a fixed area, a square. Now we're going to translate that into a 3D model. So it's safe to say that we're probably going to be working with the 3D version of a square, which is a cube. So we're going to look at minimizing surface area. So we're going to have fixed volume and lowest surface area. An example of this could be, for example, we want to bottle a 710 milliliter amount of Coke, right? So the volume is fixed, but we want to use the lowest possible amount of material to bottle this Coke. So somebody has done the research to form the bottles that you see in order to minimize the amount of plastic they use, right? So here is an example. Now, of course, you're going to find out now that the bottles that you see for Coca-Cola isn't the most efficient. In fact, the closest thing that comes to it, or the cheapest, the closest thing that might come to it would be a juice box. So Guy has 64 meter cubes of sand and wants to make a box to store it, using as little material as possible. Determine which box will have the least surface area, so the fewest amount of material. So since we're dealing where the volume is fixed and he needs to create a box with the lowest surface area so that he can spend the least amount of money in material, the closer the box gets to being a cube, the smaller the surface area for a given volume. Now, how to solve this problem algebraically? We know that a cube will provide the lowest surface area for a fixed volume of sand. You need a calculator that has a cube root button. So, most of your calculators will have something that looks like that. Okay? Your phone should have it as well. If it doesn't, your calculator might have something that looks like that, which means that allows you to type in any number in here, which in your case, you would need to type in 3. Okay? So look for that button on your calculator because you will need it. Now, why do we need it? Because when we measure volume, we measure in cubic units, right? So we need to find a number that will multiply by itself 3 times to get to 64. So instead of sitting there using trial and error, all I need to do is cube root 64. So I'm going to cube root. So up to now, for the most part, most of you have only seen a square root, which is finding a number that will multiply itself to get 64, right? So that means that what times what will give you 64. A cube root, which is this, is what times what times what will give me 64. So then if I just type this in my calculator and press equals, it will say 4. So 4 times 4 times 4 will give me 64 if I type it in my calculator. So now in a cube, I know that it's length times width times height. Okay? So which means that, well, what was the original question? Determine which box will have the least surface area. So a 4 by 4 by 4 box will have the least surface area with 64 meters cubed of sand. And we're done. Okay. So let's scroll down and take a look at. So in this example, you can try that on your own. Okay. So all you need to do is take a look at that number, cube root that number using your calculator. Okay. And then that will tell you, in our case, it was the cube root of 64 is just 4. It will give you that number, which will give you length, width, and height because you want it cubed. Okay? Hold on. Actually, you know what? I'll do that example for you as well. Okay, so the cube root of that, so we're looking, state the dimensions that will minimize the surface area of a shadow box that has a volume of that. So then I have a volume, I'm going to shift, and then 3, 5, 9, 3, 7, giving me 33. Okay, so this would give me 33 centimeters. So I know that a box, a cube I should say, 33 by 33 by 33. Therefore, a 33 by 33 by 33 box will have the lowest surface area with a volume of 35937 centimeters cubed. Done. Okay, and the last example of this week. Case number 2. We want to maximize volume, but with a fixed surface area. Okay, so let's say I only have, it's Christmas, I only have so much wrapping paper left. It's fixed, right? Like I can't change what I have left. It's Christmas Eve. I want to be able to wrap the most amount of volume with what I have. Okay, so Dorsa has 24 meters squared of wood to make a toy box. Determine which box will have the maximum volume. In the problem above, Dorsa has a fixed amount of material, surface area, and needs to create a box that will provide the largest volume to fit the most amount of toys. So the closer the box gets to being, again, a cube, the larger the volume is for a given surface area. Okay? So if I have a fixed amount of material left, and I want to form as much or create as much volume as possible, get it as close to a cube as possible. We know that the cube will provide the largest volume. Determine the dimensions of a box that maximizes the volume and has a surface area of 54 centimeters squared. So if we know that we need it to be a cube, right? And it has a surface area of 54, so let me just draw out the cube. So surface area would be that area plus that area plus that area. And I know a cube has 6 sides and it's fixed surface area. Then it's safe to say that 54 centimeters squared divided by 6 will give me 9 centimeters squared per side, right? 6 sides. Because what is surface area? Surface area is the area of the entire surface. For a cube, think about a dice, there are 6 sides to it. So each side makes this 9 centimeters squared. Okay? Now for it to be a cube, and I know that this one face right here is 9, and I know for a cube all the faces are squares, right? Which means, what would this length be? Well, what is the square root of 9? Square root of 9 is just 3, which means that for this cube, it would have to be Let me just redraw it here. It would have to be a distance of 3 here, a distance of 3 here, and a distance of 3 here. So determine the dimension that will maximize the volume. So a 3 by 3 by 3 box will have a max volume with a surface area of 54 centimeters squared. Okay, so if you have 54 centimeters squared of wrapping paper, or in this case, in this case, it's just an area of 54. It's not the previous question. So we have 54 centimeters squared. To find the maximum volume, you need to form a 3 by 3 by 3 box. Okay, so there are 1, 2, 3 questions for you to try today, and then you're done. Don't forget, all 3 need to be done by tomorrow, end of class. If you're done ahead of time, feel free to double check your work and then give it to the supply teacher. All right, have a good day. I will see you all tomorrow.